Next question in this exercise, question 145. Rationalize the denominators of the following, and we have been given 4 sub-questions. Now, in the first question, there is only one number at the denominator, and all remaining 3 questions, we have multiple numbers, well, actually 2 numbers in the denominator. So, the process of rationalization is basically we do not want an irrational number in the denominator. Here, root 7 is an irrational number. What is an irrational number? Number which cannot be expressed in the form p divided by q, where p, q both are integers. Then this will be referred as irrational number. We have difficulty visualizing a fraction whose denominator is irrational number. For example, you take one object and divide it into root 7 people. Well, that's kind of difficult to imagine. We always prefer the denominator as a rational number. So the process of converting such a fraction into a fraction where the denominator is a rational number, this process is referred as rationalization, and that's what exactly asked in this question. If you have only one number in the denominator, you simply multiply by that number to the numerator and to the denominator so that the value will remain same. So the original fraction is taken as it is, 1 divided by root 7, and we will multiply both numerator and denominator by root 7. In the denominator, root 7 times root 7 will become 7, and in the numerator, it will become just root 7. This is a better way of visualization because now we can take root 7 objects and divide them equally among 7 people. So that's a better visualization. What if, so this is your final answer. What if you have, let's take the second question. Here you have 2 numbers in the denominator. If that is the case, and if the denominator is irrational, because root 7 itself is an irrational number, root 6 itself is an irrational number. So if you subtract irrational minus irrational, you still get an irrational number. If you have 2 numbers like this one, you always multiply by the conjugate of the denominator. The conjugate will be simply change the middle sign. If you have minus, replace it by plus. If you have plus in the middle, change it to minus. Here we have root 7 minus root 6. So its conjugate will be root 7 plus root 6. We are going to multiply both numerator and denominator by the conjugate, which is root 7 plus root 6. Let's do that. So we'll take the original fraction as it is and multiply both numerator and denominator by root 6 plus 7, root 6 plus 7. Since we are multiplying numerator as well as denominator by the same number, the value of the original fraction will still remain same. So if you do that, now you'll realize that in the denominator, you have a minus b, and then you have multiplied by a plus b. We know a minus b times a plus b, that is a square minus b square. So that means individual terms will now get squared, and the middle sign will be still minus. So a minus b multiplied by a plus b is a square minus b square. Root 7 square will be 7. Root 6 square will be 6, and the middle sign will be minus. And in the numerator, 1 times this number is same as this number. So the answer will be 7 minus 6 in the denominator, because a square minus b square. And in the numerator, well, just it retains this particular part because multiplying by 1 does not affect anything. So 7 minus 6 is 1, divided by 1 is same number. So the final answer will be root 7 plus root 6, and that will be rational. There is nothing now in the denominator, so which is equivalent of 1. 1 is a rational number, so we can say with sufficient confidence that this is already rationalized. Let's concentrate the third equation, 1 upon root 5 plus root 2. Again, we will multiply. There are 2 numbers in the denominator. We will multiply by the conjugate. Conjugate is nothing but the same sequence of the same numbers. only the sign is opposite. So the conjugate of this denominator is root 5 minus root 2. We will multiply both numerator and denominator by root 5 minus root 2. So we'll take the fraction as it is, and they will multiply root 5 minus root 2, root 5 minus root 2. Since we are multiplying both numerator and denominator with the same number, the value of the fraction is intact. Again, this is a plus b, a minus b. The multiplication of a plus b and a minus b is a square minus b square. So in that process, these individual terms will get squared. Their square roots will now disappear. So the new denominator after multiplication will be 5 minus 2, because always it's a square minus b square. So here you will get 5 minus 2. Numerator, nothing really happens. You get the same term because multiplying by 1 doesn't do anything. So now 5 minus 2 can be simplified as 3. So the final answer will be root 5 minus root 2 divided by 3. And that would be your rationalized answer. Let's take this fourth sub question. 1 upon root 7 plus 2. Now, here the second number is not under root sign or radical sign, which is okay. We will still proceed with the same process. The denominator is root 7 plus 2. Its conjugate will be root 7 minus 2. We'll multiply both the numerator and denominator by the same number, taking the original expression or fraction as it is. Again, the numerator will be nothing much will happen. It's root 7 minus 2 times 1. It's the same thing. But in the denominator, you will get a plus b, a minus b. So it's a square minus b square. Root 7 square will be 7. 2 square will be 4. So now you'll get 7 minus 4 in the denominator. Numerator will be simply carried forward as it is. 7 minus 4 is 3. So your final answer will be root 7 minus 2 divided by 3. Now, since the denominator is 3, which is a rational number, this original fraction is now completely rationalized. And that's your final answer.